Introduction.
Hi Ram, how's you? I'm good, and what about you? Fine. What are you doing on laptop? I am just doing my physics assignment, alternating current. I will complete this in 10 to 15 minutes. Okay, I want to ask you something. Yeah, sure. You must know that laptop works on DC voltage as it has a battery, and laptop gets charged by plugging the charger in the AC voltage. My question is that, how is it possible that laptop works on the AC voltage?
I really don't know about that. Okay, let me tell you that laptops and many appliances also work on the DC voltage. When the charger is plugged into AC supply, then the charger converts the AC voltage into DC voltage, so that the appliances can work smoothly.
Okay, I got it. It's interesting. Tell me more about it. Children, today we will study about the alternating current.
Electric current. The electric current is defined as the time rate at which charge flows through a surface area. Let in time delta t, a net charge delta q flows through the area. The average electric current is given by delta q upon delta t. If the flow of charge is not steady, then the instantaneous electric current is given by dq upon dt. The SI unit of current is ampere. The current is in the direction opposite to the flow of electrons. The direction of electric current is taken to be in the direction of flow of positive charges. Electric current in conductors. For a current to flow in a conductor, a potential difference must exist across it. The current flows from high potential to low potential. When a battery is connected across the ends of a conductor, the surface charges of opposite sign build up on the conductor, starting from the two ends in contact with the battery terminals. These surface charges produce an electric field. This electric field causes electrons to move in a direction opposite to that of the field.
Alternating current or voltage. The conditions for a periodically varying current or voltage to be termed as alternating are following. Every cycle corresponding to one time period has half positive and half negative value alternately. In case of current, it means that direction of current reverses after every half cycle, and in case of voltages, it means that the polarity of potential difference reverses after every half cycle. The positive and negative half cycles are exactly symmetrical. The amplitude of current or voltage on both positive and negative sides remains constant in all cycles. Difference between alternating and direct current. AC cannot produce chemical effects of current, but DC can produce chemical effect of current such as electroplating or electrolysis. AC can be stepped up or stepped down by transformers, but transformer is of no use for DC. AC can be converted into DC by using electronic rectifiers, whereas DC can be converted into AC by inverters.
Kirchhoff's laws. First law states that at any circuit junction, the sum of the currents entering the junction must equal the sum of currents leaving the junction. The algebraic sum of the currents entering or leaving a junction is 0. Summation of I is equal to 0. Second law states the sum of the potential changes across all the circuit elements found when traversing in one direction around any closed circuit loop must be 0. Summation of delta V is equal to 0. Wheatstone bridge. The Wheatstone bridge is a device that can be used for measuring an unknown resistance. It consists of a battery, a galvanometer, and a network of 4 resistors. Current I flows from the battery into junction A, where it divides into current I1 and I2. The galvanometer segment between junctions C and D forms the bridge. By adjusting the values of the resistances, the current in the galvanometer is made zero, as indicated by zero deflection. At this condition, the bridge is said to be balanced. The condition of the balanced bridge is R1 upon R2 is equal to R3 upon R4. A Wheatstone bridge is most sensitive when the resistances R1 and R2 are of the same order of magnitude. Meter bridge. A meter bridge is an application of Wheatstone bridge. The apparatus is essentially a slide wire bridge in which a uniform resistance wire of length exactly 1 meter is mounted on a wooden board between 2 fixed terminals A and C, along with a parallel meter scale which can measure any partial length of the wire. Across the whole wire length AC, we connect the cell. One end of the galvanometer is connected to the middle copper strip at point D, and its other end is connected to a jockey which can be connected to any required point on the wire. A resistance box is connected across the gap G1 and unknown resistance is connected across the gap G2. At the balance state, we have S is equal to product of R and within parenthesis 100 minus L upon L. To calculate the value of unknown resistance, we have to calculate only the balancing length accurately. Potentiometer. Potentiometer. Potentiometer is generally employed to compare the EMFs of 2 cells or any 2 sources of EMF. Potentiometer may also be used to determine the internal resistance of a cell, to measure current, to calibrate an ammeter or voltmeter, to compare resistances, and for the measurement of thermoelectric EMF.
Electrostatic potential. Electric potential of an electric field at a given point is defined as the amount of work done in bringing a unit positive charge from infinity to that point. Electric potential is measured in volt. If 1 joule work is done in moving plus 1 coulomb charge from infinity to a point in an electric field, then the potential at that point is 1 volt. The potential difference between 2 points A and B is given by VAB equals WBA upon Q naught. The potential difference between 2 points in an electric field is equal to the amount of work done in moving a unit positive charge from lower to higher potential point. Definition. In our everyday life, electromagnetic induction plays a vital role. Transformer, generator, train, and telephone are some examples which work on the principle of electromagnetic induction. An electric current can be produced in a circuit by a changing magnetic field. The current in the coil brought about by a changing magnetic field is called an induced current and is said to be set up by an induced EMF in the coil. The phenomenon of producing an induced EMF with the help of a magnetic field is called electromagnetic induction.